Hi, today we're going to be talking about exact values. For instance, in example 1, find the exact value of sine of 45. Now, you may think that you can just go to your calculator and type in sine of 45, and this is a value, 0.7071067.812, but unfortunately it's not the exact value because the exact value would actually be never-ending decimal, which we could never write. So we want to find out what exactly sine of 45 is. In order to do this, we are going to first draw. Again, everything comes from our unit circle. So we're going to draw where 45 degrees is. And here's 45 degrees. And then remember, the triangle is always formed by going back to the x-axis. And you know if that's 45 and that's 90, then technically you know this one is also 45. Well, a 45, 45, 90 degree triangle is actually a special right triangle. It has a certain relationship in the sides, and I have it illustrated in the gray box. So in a 45, 45 degree triangle, this one, the relationship of the sides are the ones across from the 45 are in a 1-to-1 ratio, and across from the 90, that side is radical 2. Now that should make sense because if these two are in a 1-to-1 ratio, you could do a squared plus b squared to get c squared, and you get radical 2. So going back to my triangle now, across from the 45 would have a 1 side. Across from this 45 would have a 1 side. And across from the 90 would have a radical 2. So now that we have all three sides of the triangle, we are now able to set up sine, because sine of an angle is equal to the opposite over the hypotenuse. All right, so across from the 45 would be my opposite. Across from the 90 would be my hypotenuse, and the last side would be the adjacent. So the opposite side is 1, hypotenuse side is radical 2. Now the only other thing you have to consider is that the values will go from positives to negatives depending on what quadrant you're in. So since we're in the all positive quadrant, this will be a positive. Now this is technically the answer, and I will even show you. Sine of 45, there's the decimal. If I were to put in my value right now, it's the same number. Now the one other thing we have to do is to rationalize. So to rationalize, we're going to multiply the radical in the denominator to both numerator and denominator. And that is the exact value. And if I put that one in, you'll actually see that that also as well is equivalent. So this is the most precise answer. Radical 2 over 2 is the exact value. The decimal is just an approximation. Okay, so now we're going to try this again. Cosine of 210. So we're going to draw our angle. 210 is going to spin around like this. I'm a little off. But then you're going to draw your triangle up and over. So now we have to figure out what this space is right there, because that's the corner angle of the triangle. Even though we're trying to get the cosine of 210, it really is going to refer to that triangle. If this is 180, and this is 210, you're off by 30 degrees. So that must mean that this corner angle is 30 degrees. All right, and if that's 30 degrees, and that's 90, then by default, we know that's 60 to make a triangle. And the 30, 60, 90 is another triangle whose sides are actually special. So I'll get my highlighter. The 30, 60, 90 triangle. Across from the 30 is 1. and across from the 90 is 2. Okay, that means that those two sides are in a 1:2 ratio, and across from the 60 is radical 3. All right, so let's see. Here's my 30. Across from the 30 is 1. Across from the 90 is 2. And then across from the 60 is radical 3. So if I want to do cosine of an angle is equal to A over H. So in my problem, the A side is, well, let's see, across from the 30 would be opposite. We're always going to use that angle right there. Across from the 90 is H, and this side is adjacent. So adjacent would be radical 3. Hypotenuse would be 2. And then again, I have to consider what quadrant I'm in. A, S, T, C. I'm in the T quadrant, which means that tangent is positive, but cosine is negative. So I have to make sure that I put a negative sign on my answer. And that's it. We don't have to rationalize. That is the exact value of cosine of 210. So these values are coming from those two special right triangles, the 45, 45, 90 or the 30, 60, 90. The ones that I'm going to ask you to find the exact value of are going to only involve those two triangles. So I would never ask you to find the exact value right now of like sine of 18 because you don't have something to help you find that. And again, if you really want to check your answer, cosine of 210. And then if I put my value I just got in, negative radical 3 over 2, I can in fact see that that matches. Now, most of you guys are going to probably not want to go through the triangles each and every time, but that's where they're coming from. Most of you guys are probably going to prefer to memorize the values, and it's really simple to memorize. There's a quick pattern you can do. So what we're going to do is just create a table of values that I can look at rather than setting up my triangles each and every time. So in order to create the table, we are going to write the three main angles, 30, 45, and 60 in numerical order. Then we're going to write sine, cosine, and tangent. The sine and cosine rows, those all have two denominators. If we were to find all of these using the triangles, this is what would happen. These would all have two denominators, and these would all have two denominators. All right, then the numerators will actually follow this pattern. 1, radical 2, radical 3. Cosine would be in reverse. Radical 3, radical 2, 1. Now to get the tangents, remember that tangent is O over A and sine is O over H. I'll just write them for a second. So the O side and the A side make the tangent. So all you have to do is get the numerators of each of the cosine and sine and put them together. So O over A, O over A, and then O over A. Now those can reduce. Radical 3 over 1 is just radical 3. Radical 2 over itself reduces to 1. And this other one is just the bad one because we have to rationalize by multiplying by radical 3 over 3. And you get radical 3 over 3. So if you can memorize the chart, then you don't have to set up the triangles. If you don't want to memorize the chart, then you're going to have to memorize the triangles. So you're going to have to memorize one or the other. All right, so we're going to try this 4 more times. And I'm just going to, from now on, strictly do it from the memorizing the chart method. Oh, I'm sorry. Let me go back. What I wanted to do is just show you how the table works first off. So let me get my highlighter. So if you want to find the sine of 45, you would go to the sine, you would find 45, and then that is your value. So we could find it just that fast. The only thing you still have to do is know that you're in quadrant 1 and that's positive. So now let's do the other problem. To do the cosine of 210, you still would have to draw it out and you would still have to figure out that you're using a 30-degree angle. But once you do, you would go to now cosine, you would go to the 30, and you get that value. And there it is. And then all you have to do is figure out that it's negative because you're in quadrant 3 and cosine is negative. So it's definitely a lot easier to find the values that way than to do all the sides of the triangle. Okay, so examples 3, 4, 5, and 6 are all going to just be that type of problem. So example 3, find the exact value of negative 120. Okay, so I'm going to do it the chart way, but first I have to know what angle I'm dealing with. A negative 120 does not mean my answer is going to be negative. A negative 120 just means it rotates down. Okay, so that means it's going to rotate this way. And that's my negative 120-degree angle. But I always have to know what's the triangle right here, and I need to know this angle right there. Again, just do a visual approach. Those two angles form a line. So if on the right it's 120, this has to be 60. All right, so now I know I'm really talking about a tan of 60 and not the tan of 120. So now that I know what angle I have to reference, I'm going to now make my chart. And I'm just going to make this chart one more time for this page. So we're going to have our sine, cosine, and tangent. We're going to have our numbers 30, 45, and 60. Our sine and cosine rows have two denominators. Our numerators go up in order: 1, radical 2, radical 3. Our cosines go in reverse order. And then to get tangent, you just put the two green numbers on top of each other. So 1 over radical 3, which can rationalize, radical 2 over radical 2, which is 1, and radical 3 over 1, which is radical 3. So this is the only one I have to rationalize, and it's going to come out to be radical 3 over 3. Okay, so now I know it's a 60. I'm going to use my highlighter so you know exactly what I'm referencing. So tan of 60 is really what I'm going to reference. Tan of 60 is radical 3. So this is going to end up being radical 3, and then all I have to know is if it's positive or negative radical 3. ASTC, I'm in the T quadrant, which means tan is positive. Now, you can always get it by just typing it in yourself. You can even try to check the values, tan of negative 120, and then my positive radical 3. And you can see they're the same number. Okay, example number 4. Find the exact value of sine of 5 pi over 3. Well, I can convert all my degrees to radians, but in all honesty, it's actually easier if you change the 5 pi over 3 and convert it to a degree like you did last class. So I'm going to do it the fast way. The fast way to do a conversion is to do 5 and replace pi with 180. And then you can do this in your calculator. I'll just compute it by hand. This is going to be 300. So 5 pi over 3 is 300. You can do your ratio proportion method if that's what you like. So all I have to do now is see where my angle is. 300 rotates to here. I make my triangle. If this whole thing is 300, then this angle right here is what I'm looking for, and that's going to be 60 again to make a circle. So what I need to do now is find the sine of 60 really in my table. Okay, sine of 60 is right there, radical 3 over 2. So I'm going to put a radical 3 over 2, and then the only other thing I have to do is figure out if I'm positive or negative. I'm in the C quadrant, which means cosine's positive. This will be negative. And I could check that using my calculator, like on a test or quiz, I would do that. All right, example 5 and 6. If you notice, 5 has secant in it and 6 has cotangent. And our table only shows sine, cosine, and tangents. These are not actually incredibly difficult. You know that secant is the reciprocal of cosine. Right, so that goes with cosine, and cotangent goes with tan. So all we have to do is take the values in our table and reciprocate them once I know which angle to use. So we're going to start off the same way. I'm going to draw my, excuse me, I'm going to draw my angle, 315. So that's 315. Draw my triangle up. I really need that piece. But if that's 315, then this has to be 45 because 315 and 45 make a complete circle of 360 degrees. Okay, so now I know to look at my table. I'm really looking for cosine then of 45. So cosine of 45 is radical 2 over 2. But I don't want that because I want secant. So I need to reciprocate it. All right, so that's cosine. And I need secant. So it's going to be 2 over radical 2. And then I need to know if it's positive or negative. So we're in the C quadrant for cosine. Cosine then is going to be positive, so this will be positive. That is the answer, but we just have to rationalize it by multiplying the radical 2 out. And then you're going to get 2 radical 2 on the numerator, and then 2 on the denominator. And then this actually reduces. Those 2 cancel out, and you're left with radical 2. Now, in order to check this, to do secants, you guys with an Inspire actually have a secant button in your trig menu, but on the 84 you don't. So if you really want to check this, to do a secant of 315 on an Inspire or on an 84 calculator, you would have to actually use the reciprocal. So you would do 1 over cosine of 315, and that would represent secant. And then if I now do radical 2, you get the same value. Okay, example 6. We'll try one more of these exact values. Find the exact value of cotangent of 2 pi over 3. So exact value means I don't want the decimal. So I'm going to convert. I'm going to do it the easy way. 2 times 180 over 3. Again, use your calculator. I'm going to do it by hand. This is going to be a 120 degree angle. All right, so now that I know what the angle is, I'm going to plot that. Oh, I'll circle that. That was for that problem. So 120 lands right there. That's 120. But I really need to know this triangle here. So that's going to be 60 to make 180 for the line. I now know to look up. I now know to look up really tangent of 60. So tangent of 60. Oh, sorry, that came out black. Tangent of 60 is radical 3. So I now know it's going to be radical 3, but I have to reciprocate it because I'm doing cotangent instead. So it'll be 1 over radical 3. ASTC, I'm in the S quadrant, which means tangent will be negative. Then I'm just going to rationalize it. And that's my value. Okay, moving on to the next page. This is all going to be using that information we just were doing on the last 2 days, or last 2 pages. Example 7, in the accompanying diagram of a unit circle, the ordered pair xy represents the point where the terminal side of theta intersects the unit circle. If theta is 150, what's the value of x? So I know it's very wordy and it sounds really complicated, but basically you're on a unit circle. So if you're on a unit circle, you know that the significance of x and y is that x is cosine, y is sine. Okay, our school CNS, so cosine then sine. So if this is 150, we still, just like we just did, want to really make that triangle and then figure out that this corner angle is 30. So the sine, x is going to be the cosine of 150. That's what x is going to equal. What's the value of x? So when I find the value of cosine of 150, I make my triangle, I get my 30. So then I'm going to make my chart. And instead of making my chart again, I'm going to flip back to the last page. I need to look up cosine of 30 is what I really need to look up. So cosine of 30 is radical 3 over 2. So I know it's going to be radical 3 over 2. And then because I'm in the second quadrant, and that's the sine quadrant, that means cosine is negative. Now it is a multiple choice. So as long as you knew it was cosine of 150 for the x value, you could have just done this, went through each choice, and then you could have also just matched the values. And it is the same. All right, example 8. Example 8 says to express the cosine of 220 as a function of a positive acute angle. Now, this is not asking you for the exact value, because if we do try to, in fact, draw the picture, which we're going to need anyways, so we'll do it now. 220 looks like this. So I need to know that spot. And if this is 180 and that's 220, we went past it by 40 degrees. So we don't have a 40 degree in our special right triangle chart. We only have 30, 45, and 60. So they're not going to ask you for an exact value of this. But if, like back when I was in high school, we used to have actually trig charts, and they would list every angle from 0 to 90. So saying that I had that big massive trig chart, what it's saying is what basically would you look up in the chart? This is what really this is saying. So you would keep the cosine, because you would reference the cosine row. And then what you would do is instead of looking up to 20, because it only goes up to 90, you would reference the 40 degree angle. And then you'd have to know to negate it or not. And to understand if it's negated or not, you have to know what quadrant you're in. So we're in the T quadrant, which means this would be negative. So you put the negative in front to illustrate that it's going to be a negative value. So that's what we would do. To find cosine of 220, I would actually negate the cosine of 40 row, and whatever that value turned out to be, that's what I would do to it. So that's all they want, is to just say what you would reference on this big massive chart. So example 9, cosecant of negative 250 as a function of a positive acute angle. Now that cosecant really goes with sine. Keep that in mind. I'm going to draw my angle. Negative 250 wraps around this way. Okay, remember this is still, that's negative 180. So we went by negative 180 by a difference of 70. So this is actually a 70 degree angle. Now, even though we look up sine, we don't change the function, because I can't just take sine. I have to say what it's equal to. It's still equal to cosecant. I'm going to use the 70. And then I'm still going to take the sine value and switch it. But in the end, it's still going to be equal to cosecant 70, not sine of 70. Okay, ASTC. We're in the S quadrant. That means S is positive. S is positive. And that's what those two would be. Cosecant of negative 250 and secant of 70 are the same. Oh, I'm sorry. I also should go back to the example 8 and show you. You can even check yourself. You could type in the cosine of 220 and then the negative cosine of 40, and you'll see that it's the same exact value. If you want to check this one, cosecant of negative 250, remember inspires you're fine. On the 84s, you would do 1 over sine of 70. And then you would do, oh, I should have done the other one first. Never mind. I'm going to do the cosecant of negative 250 the same way, which is 1 over sine of negative 250. And you can see that they're both the same. All right, last page. 10, 11, and 12 are just find the values of them, but notice they didn't say exact values because you could not find the exact values of these. We're going to round all of these to the nearest 10,000s, so that's okay to just key enter them. The only thing is, how do you key enter them? Okay, well, tan of 142 is easy. Tan 142, you're fine. That's your value. 10 thousandths is 4 decimal places. I look over here, that's an 8, so it's going to round the 2. So it's negative 0.7813. Find the value of 53 degrees, 45 minutes. All right, so this is the new thing. How do I find those symbols? So when I type in the sine of 53, I got to now differentiate between degrees and minutes. On the 84, you do second apps for angle again, just like we have DMS. And then you'll see 1 and 2 are your degrees and minutes symbols. On the inspire, you're going to press the symbol that has the question mark symbol. And the question mark symbol should have your degree symbols and your minute symbols. The degree symbols is the 4th on the top, and the minute symbol is the 5th on the top, under the question mark key. Okay, so we put that in. We put in 45, and then our minutes. And then that's all I have to do to find that, nearest 10 thousandths. So 0.806, and then 4 does not round. And then for example 12, to do cosecant of 213 and 25 minutes, I already showed you that to do cosecant inspires, you have that key. On the 84, you just have to use the reciprocal function. So it's going to be 1 over, and cosecant goes with sine, so sine of 213 degrees, 25 minutes. And your answer is negative 1 point. Okay, 7's going to be rounded because of the 9, so 8158. All right, we're still talking about values, so we're going to talk about one more thing to do with values. If x, for example 13, if x is a positive acute angle, and sine of x equals cosine of 20, find the value of x. So basically, this is saying that the cosine of 20 is actually equal to the sine of what angle? Those two actually have the same values. I don't have to find the value, I just have to find out what the angle is. I'm just going to insert a blank page for a second to help you understand this. And you don't have to write this in your notes. All right, if we're talking about a right triangle, then you know for a fact that if this is 40, this is 50, right? Those two angles add up to 90. All right, try it again. If this is 20, you know that's 70 because those have to add up to 90 because the other corner is already a 90. All right, so the special relationship is that angle A plus angle B make 90 degrees. All right, now if I were to illustrate what I want to show you, I'm going to write sine A, cosine A, tangent A. And then I'm going to write, you know, your cosecant A, your secant A, and your cotangent A. I'm also going to do sine of B, cosine of B. And again, you do not need to write this. Just want to illustrate my point. So let me make up some numbers here. Let's pretend that this is just a 3, 4, 5 triangle. So I don't care what the angles are right now. Just want to show you what the relationship is. Sine A, well, here's the A angle. So this would be opposite. This would be a hypotenuse. And this would be adjacent. So the sine of A would be 3 over 5. And then this would be 5 over 3. The cosine of A would be 4 over 5. And secant would be 5 over 4. And tangent of A would be O over A. So 3 over 4 and 4 over 3. If I were to now switch and do the B angle, what happens now is this side makes the opposite. And this side becomes the adjacent. So if you notice, it's the same 3 numbers, but the only difference is O and A got swapped. So sine of B now is going to be 4 over 5, and this is going to be 5 over 4. Cosine of B is going to be 3 over 5, 5 over 3. And the tangent of B now is going to be O over A, which would be 4 over 3. And this would be 3 out of 4. Now, if I compare the values, sine of A right here is actually equal to the cosine of the other angle, B. I have cosine of A is actually equal to the sine of B. I also have the tangent of A is equal to the cotangent of B. Oops, I wrote my number wrong there. I apologize. All right, and I could keep on going through that. But if you notice, sine and cosine have a co-word in front. Tangent and cotangent have a co-word in front. And secant and cosecant have a co-word in front. Those are called cofunctions. And again, you have sine and you have cosine. You have secant, you have cosecant, and you have tangent, and you have cotangent. So I call these the co-buddies. As I just illustrated, because O and A get swapped if you change angles, the sine of the one angle is actually equal to the cosine of the other angle, and the relationship between the two angles is the two angles add up to make 90. So we have sine and we have cosine. So I know that if I switch functions and they're the co-buddies, I know the relationship between that angle and that angle is that they need to add up to 90, and those values will be the same. Now, you don't have to set this up, but technically this is what I'm thinking. I know the two angles have to add up to 90. So x is 70. Now I could check this. The sine of 70 that I got is that, and the cosine of 20 is also the same thing. Okay, so for the last problem, one more of these types. I have if x is a positive acute angle and tangent x equals cotangent of 2x minus 30, find the value of x. So if I have tangent and I have the co-buddy, the cotangent, I'm talking about cofunctions, I know that they're going to be equal when this angle and this angle add up to 90. So I just set up that statement. I know that x angle and the 2x minus 30 angle together have to add up. In fact, let me use a different color. They need to add up to equal 90. So now once I set that up, now the rest is just pure algebra. Combine like terms, add over the 30, and then divide. Okay, and if I were to fill that in, I would in fact get that tan of 40 equals the cotangent of 2 times 40 minus 30.